Getting ready for 6th grade, Lesson 3, Essential Question. How can you factor numbers using a factor tree? For today's lesson, we need to remind ourselves of what a prime number is. And a prime number is any number that is greater than 1 and only has 1 and itself as factors. Some examples of this would be 3. You have 3. If you list the factors, you have 1 and 3. Nothing else will give you 3. 2 is the only even number that is prime because you have 1 and 2. 5, 7, 13, 17. You can't multiply any numbers to get those, and so they are considered prime. Unlock the problem. Mr. Shu gives this puzzle to his math students. Write 24 as a product of factors that are prime. Remember that a prime number must be greater than 1 and can only have 1 and itself as factors. So before we get started on how to do this, right here it says give an example of a number greater than 1 that has only 1 and itself as factors. So they are asking for an example of a prime number, which there are lots. You could have 2, 3, 5, 7, 11, 13. Those are the first few and the most commonly used. So to actually solve the puzzle, you can use a diagram called a factor tree to find the factors of a number. And so we're going to practice that. Use a factor tree to find the prime number factors that have a product of 24. Step 1 is to write the number to be factored at the top of the factor tree. So this is like the star on a Christmas tree. And our number is 24. Step 2 is to write it as a product of any two factors. They're going to have you use 4 and 6, but you could have easily used 12 and 2 or 8 and 3. It doesn't matter because you would still end up with the exact same prime numbers at the end. But let's just walk through it with them using 4 and 6. So we're going to write 4 and 6 right there, and you can see that our tree is getting larger at the bottom. And step 3 is to write each of factor as the product of two factors. So now instead of breaking down 24, we're going to be looking at each individual one. So 4, what can you break 4 down into? Well, 2 times 2 equals 4. And then now we're going to be looking at 6. They broke it down into 2 and 3. You can break 6 down into 2 and 3. And then step 4 is to continue until each factor is a prime number. So let's look. Is 2 a prime number? You can't multiply any two numbers to get it except for 2 and 1. So that one is a prime, so I'm going to circle it. And that one's a 2, this one's a 2. 3 is 3 prime. No factors except for 1 and 3, so it is a prime. So I'm going to circle it as well. All my bottom numbers are circled, and so I have my primes. So now I need to write all of the factors that I circled that are the prime numbers from least to greatest. So I have 2 times 2 times 2 and then 3. So 24 equals what? Prime factored out. And this is actually called prime factorization. So we can write it out as 2 times 2 times 2. I have 3 of them. And then times 3. Or we can write it a different way, which is a lot easier. And if you remember your exponents, then it's really simple. And so how many 2's do we have? We have 2 times 2 times 2. That means there's 3 of them. So that means we have 2 to the third times 3. That is it written in exponential form for the prime factorization. So now let's look at the try this. And the try this says make a different factor tree for 24. So like I mentioned earlier, what other factors can we use to break 24 down? And their question is the product of factors the same as in the example? So instead of using 6 and 4, you get to choose another factor pair that equal 24 and create your factor tree. Press pause while you create your own factor tree. Here's one example. If we break it down into 3 times 8, 3 is a prime number, so I circled it right away. And then I broke 8 down into 2 and 4. I circled my 2 because that's a prime number. And then 4 breaks into 2 and 2, so I circled those. I still ended up with 3 2's, 1, 2, 3, and 1 3. So if I put them in order from least to greatest, I still have 2 to the third times 3. So let's try it with 12 and 2. So if I have 24, I have 2 and 12. 2 is a prime number. 12, I could break it into 3 and 4, or I could break it into 2 and 6. I'm going to do 3 and 4. 3 is a prime number. And then 4 breaks into 2 and 2. Both of those are prime numbers. Let's see, my bottom, I don't have any more to break apart, so I have 1, 2, 3 2's and a 3. Either way, I end up with 2 to the third times 3. So let's look right here real quick on Math Talk. It says explain how you can use factored numbers to find common factors. So if I had done 2 different numbers, I could find some common factors because you can see numbers that would be the same on them. So common means same. So factor trees would help you see the breakdown, especially in the prime numbers. I apologize for the quality of my picture, but you have your own paper to be looking at as well. And so make sure that you read your directions. You're going to be creating factor trees down to the prime numbers. And I know that it doesn't ask you to do this, but I want you to practice using your exponential form. So if you have more than one of the same factor, write it as an exponent. Press pause while you work. Remember to check your answers for the share and show, and then press pause before you work on your own. Number 1, they're giving you the product of 210, so let's write that up at the top of your factor tree. Now that looks like a big number, but it ends in 0, so that means that you can multiply it by 10, and they gave you 21. So is 21 times 10 210? Yes, it is. So we're going to go ahead and do that and fill it in your second level. And then break down 10. So 10 breaks down into 2 times 5. And 21 breaks down into 3 times 7. So let's fill that in on our factor tree. 10 breaks down to 2 times 5. 21 breaks down to 3 times 7. Now let's circle our prime numbers. Is 2 prime? Yes. Is 5 prime? Yes. What about 3? Yep. And is 7? So they all are prime. That means they all only have 1 and itself as factors. And they're asking us to write it in order from least to greatest. So let's rewrite it. So 2 is the least, and then 3 and 5 and 7. Are we able to rewrite any of this as an exponent? Nope. We only have one of each factor listed. So 210 prime factorization is 2 times 3 times 5 times 7. For numbers 2, 3, and 4, I'm going to be showing you some possible factor trees. The only thing that we need to have exactly the same is going to be our answer, so the actual prime factorization. The way that you work your tree to get there, it doesn't necessarily matter because there's a lot of different paths that we could take to end up at the same place. The answer for number 2 should be 2 times 2 times 2, or 2 to the third. On number 3, I broke it down into 5 and 9, but you could have broken it down into 15 and 3. But your final breakdown should have been 3 times 3 times 5, which written in exponential form is 3 squared, or 3 to the second power, times 5. For number 4, I broke 350 down into 10 and 35. And then 10 breaks down to 2 and 5, both of those are prime. 35 I broke down into 7 times 5, so if I rewrite them, I have a 2 times 5 times 5 times 7, so in exponential form, that would be 2 times 5 to the second power times 7. One thing you have to be careful of with factor trees is that you're staying organized and you're writing nice and neat. It's very easy to miss a factor when you're filling out down here your actual answer because you've become kind of messy. I've done it, believe me. So try your very best to stay organized so that you make sure that you get all of your numbers into your answer. So now press pause while you work on the on your own and the problem solving sections. Remember, when on the on your own, it's the final answer that needs to be the same, not the path that you took to get there. Number 5 should end up being 2 to the second power times 3 to the second power, or 2 times 2 times 3 times 3. Number 6 should end up being 2 times 2 times 2 times 3 times 3, or 2 to the third times 3 to the second, or 2 cubed times 3 squared. And number 7 is a good example of how exponential form makes it easier to write it out. So you would have 2 times 2 times 3 times 3 times 3 times 5, or 2 squared times 3 cubed times 5. On number 8, when it asks you to just write as a product of a prime number factors, I mean, these are all multiplication, so that's meaning that their answer is a product. So he just wants them to break down 500 into prime factorization. So the answer to number 8 is 2 times 2 times 5 times 5 times 5, or 2 to the second times 5 to the third. On number 9, it says find a number that has 4 identical even factors, and each factor must be greater than 1 and can only have 1 and itself. There's only one even prime number. So, if you only have one even prime number, that's the number you have to use. And your answer should be 16. 2 is the only even prime number. 2 times 2 times 2 times 2 ends up being 16.